To the feasibility of small scale wind turbines in Uzbekistan. Basically, this project is a research based for the generation of energy demand in Uzbekistan. So that's why we have developed this complete the global energy demand with climate urgency lead to transition to renewable energies. So the thing is that the Uzbekistan country also need to shift their energy patterns from fuel to renewable energies. Okay, in the renewable energies, we consider first of all the wind turbines case in which we need to um, decrease the natural gases with the consumption and the pollution challenges. Okay, so this paper investigates like how small wind turbines provide the sustainable energy to rural or off-grid regions of Uzbekistan. The system in this system has a DC generator with a AFN ANFIS, basically a controller, which is a buck converter to enhance the efficiency and reliability. The thing is that we are just using here the ANFIS controller for the performance controller uh, using the buck converter and ensure that maximum power conversion efficiency in the um, Uzbekistan's renewable wind energy. Okay, so we in this research we have just find out that the small wind turbines are more efficient than the solar PV like sunlight energies. Okay, so I have written this complete abstract with the introduction, like how we can shift the renewable energies to greenhouse gases with ensure energy efficiency. Okay, so yes, introduction. I have written the complete details of introduction with the green Uzbekistan, like how we can do a green Uzbekistan. Our mission is we need to generate the energy till 2020, 2030, like 2030. And our first initial scale, in the initial scale, we have just a plan of 500 megawatt wind power plant in the Uzbekistan, and so that's why this in the next till 2013 we our aim to develop 3 gigawatt energy power plant for the Uzbekistan. Okay, so this is the complete introduction with the literature review, and this is the system modeling, like how we can use the power wind equations, how we can use the power coefficient with the theta lambda. Lambda is basically the angular velocity and the turbine rotor and with the turbine blade as well. All the equations used in this paper I have used, and next part is basically this is a wind turbine characteristics. Characteristics is just a second. Yes, this one. Okay. Characteristics defines the turbine power characteristics with the pitch angle uh, according to the wind turbine speed and the turbine angle output power. Okay. So these are the output power, and horizontal side it represents the turbine speed. Okay. So yes, this one I have written the complete DC generators where buck converter design, and yes, this is a buck converter design circuit and continuous conduction mode like CCM, we have added for to efficiency to generate the efficiency of the system. And then I have used a duty cycle with forward controller mechanism, and yes, all the controller design and everything is added here. This is a pi controller used in a feedback controller, and next I have added the ANFIS structure, which is based on the torque and input voltage and provides the duty cycle, which normally stabilize the power of wind turbine. And this is the surface view of ANFIS controller. Basically, this is just graph generates in MATLAB code. So results is that we have just got the results. We have in the generation of 1 kilowatt power out of 366 days. Data is available only 27 days that wind speed is unable to generate mechanical power above 1 kilowatt, but it normally produce 1 kilowatt energy per day. So like the average power of this year is 6.3 kilowatt, which is indicated in figure 4. I have just written, and like this is a figure 4, like this one. So yes, this is a daily mechanical power of the year here, and power is almost its efficiency is very good, and we have just generated the average power. We called it 20 kilowatt, uh, like we called it per month. Okay, 20 to 30 kilowatt is average. Okay, so monthly mechanical power available in this year, like we have just generate almost in monthly basis, we just say it is almost 5 to 10 kilowatt power per day per month. Mhm. So this is a complete Simulink model we have used, and the constant speed. And next one is these are the output graphs we have added here, like constant simulation using pi controller, and these are the constant simulation for the ANFIS. Basically, in these graphs, we have just generated the wind torque, input voltage, output current, power, and duty cycle as well. So yes, and the next part is basically we have added the variable simulation using pi controller, which is basically the behavior of wind torque, input output voltage, output current, and power and duty cycle is changed. So when we just change the pi controller proportional integral values, then it provides the changes in the these different like wind torque, input output voltage, current, power, and duty cycle as well. Okay, so this is also the variable simulation for fuzzy logic controller. So yes, and next one I have added the conclusion and the references. Okay, so let me just also show you, here are the MATLAB files, which is a wind turbine for 1 kilowatt, and these are the just a second. Yes, this one is the MATLAB model I have just opened for you, and this is a MATLAB function which is used in it, and for the daily wind speed Uzbekistan, this is a MATLAB function for use, and this is a MATLAB Simulink model as I just added in the, like, see in the MATLAB Simulink model. This is a complete model and everything is added. So you need to just check it this paper, and if you need to ask anything, you just call me and I will answer your questions. Okay, thank you.